MAP4C 3.3 line of best fit. A line of best fit is also referred to as a regression line or trend line, and it is a line drawn through data points to best represent a linear relationship between two variables. In a scatter plot, a point that lies far away from the main cluster of points is an outlier. An outlier may be caused by inaccurate measurements, or it may be unusual, but still a valid result. The line of best fit should reflect all valid points from the data set, including outliers. So here we see our line of best fit going through the data, through the middle, and this is our outlier. It's far away from the main cluster. So we're going to investigate the effects of outliers on the line of best fit. Looking at these three graphs, which is the line of best fit? So, looking at each example, graph A goes through the main cluster. It does not consider the outliers. Graph B suggests that the main cluster and the outliers are equally important because it's equal distances between each. Graph C is slightly below the main cluster towards the outliers. So it has only 2 data points down here, so it's not as significant as the previous example. And this would be our best line, our line of best fit. So why do we have a line of best fit? We use this to make predictions. Regression is an analytic technique for determining the relationship between a dependent and independent variable. Linear regression is an analytic technique for finding the equation with the form y is equal to ax plus b that best models the relationship between two variables. So when we are using this line to make predictions, we can make predictions within the data set. So here it's highlighted in red because this is between the minimum x value in the data set and the maximum x value in the data set. So we call this interpolation. It's an estimate using the regression model between two known values. Predictions within the data set, interpolation, are often more reliable than the opposite, which is extrapolation. This is an estimation using a regression model that is beyond the data range. Approximations that are further from the data set are less reliable. So as we get further along this line, away from the data, it's a prediction, but it's getting less and less reliable as we go further away from what we've actually observed. So outliers in a data set are significantly far from most of the data and can reduce the accuracy of a model in small samples. So we have increased reliability with larger samples. So using the graph and the equation of a line of best fit to make predictions. So if we use the graphing method, we draw a line through the middle of the data and use the line of best fit to estimate y. And this y estimate just means that that's the prediction of our linear model for that particular value of x. So drawing it by hand is not as accurate as using technology, and we're going to have to eyeball the value sometimes using the graph. What value do you see on the y-axis for a given point? So let's use the example when x is equal to 8, what does our model predict? Even though we see here the actual data point observed 810, our model is this line, and it predicts approximately 12. So when x is equal to 8, the estimated value of y is 12. Now using the equation, notice that the equation was provided using Microsoft Excel, the spreadsheet software. We can use this equation to make predictions for x. All that we need to do is substitute into the equation with the variable x to get the approximated value of y estimate. So here's an example of interpolation. If I substitute in x is equal to 6 into the equation, it's going to tell me this value. So substitution of x is equal to 6, evaluate the right-hand side using a calculator, that's approximately 9.7. So this is easier or more accurate than doing this by guessing using just the graph. Next, an example of extrapolation is when x is equal to 12, because this is beyond our maximum value of x. This is a prediction that is outside of that range of our observed data. And we would expect it to be somewhere around 17, but looking at our substitution of x is equal to 12 into our line of best fit equation, we get 17.2, even more precise. So Using pencil and paper, we'll follow these steps. Label the dependent and independent axes. Y depends on X, so it's helpful to remember that relationship if there is causality. Step 2, use an appropriate X scale and Y scale. So in this case, the X scale is 1 square equals 10 units, so 10% in this case. And that is enough to make sure that all of the data is within our window in a reasonable space. The equation of a line is y is equal to mx plus b. So we have to find out the two components, m and b, where m is the slope, b is the y-intercept. Slope can be calculated using rise over run, but when the x scale and y scale is not 1 to 1, meaning 1 square representing 1 unit, it's helpful to use the point slope form. So the point on the left is x1, y1. The subscripts are just names in mathematics. This is the first point on the left-hand side. And the subscripts for the next point just tell you that this is the second point. And y2, 70, minus y1, 43, minus x2 minus x1. This will tell you the rise over run. The y-intercept, if you're using pencil and paper, is just where does that line intersect the y-axis, and it's approximately 7 or 8. So that should be adjusted. I meant to say 8. Good. We'll make that adjustment here as well. State the equation of the line of best fit. If this is our x scale, it's 10. That was less. So we state that equation when we have the slope 0.9 and the y-intercept of 8. Now, a much more technical and accurate method is to use a spreadsheet. So here's the data, and what we're going to do is use Microsoft Excel. So this is our end result. It doesn't take too much effort to get there, so I'll erase it and get started. So we enter this into cells. We click and drag over the area that we want to graph. Click Insert. A menu comes up for scatter plots. When I click on this, it's automatically generated. So left click on the data values, right click to get the drop down menu to add trend line. Then a variety of models are available. We'll stick to linear, but we'll display the equation on the chart and the r-squared value on the chart. So I'll click and drag this over, and our title should be y versus x. So y is the exam mark, and we're saying that that is dependent on the term mark. We would expect that someone who does well in the term would do well on the exam. There's a positive correlation between the two variables. And if we want to add our labels, make sure you click on the chart area. Chart design is the menu that you need, and add chart element, axes titles, primary, horizontal. This is term mark as a percentage. And once more, axes title, primary, vertical, exam mark as a percentage. So we have a lot of information. Keep in mind we talked about the correlation coefficient R. R squared is the coefficient of determination which is used for any type of regression model. Again, not every single relationship between two variables is linear, fitting a line. So this is a way to be able to judge the fit of a regression model to the data. So this seems to be a very strong fit. So instructions are included here. Now, not all relationships between variables are linear. If we have this right here, this graph says world record for women's 500-meter speed skating. It seems like the rate in which the time or speed in seconds is decreasing is rapidly decreasing at first and then gradually decreasing. And if you can think about it, from the 70s until now, there's been a lot of advancements in sport nutrition and science, and a lot more funding into these programs. So we've improved the abilities, but you notice that it's not as steep as you get here, and that a linear model would only work in a small range. So over a small interval, a linear model may provide a reasonable fit for nonlinear data, but it will not be reliable at the extremes. A linear model may be unreliable in these situations. The model is based on too few pieces of data. Larger samples are more reliable. The model is based on data that are clustered together. So if it's not over the span of all the possibilities, we're not seeing the overall trend. There does not appear to be any correlation. If it's a weak correlation, then it's not a reliable model. There are outliers. Outliers, as discussed earlier, can affect the line of best fit and therefore affect our predictions. The data does not appear to be linear, as we see in this case here.